I want to take a few minutes to discuss our aquaponics build, discuss the process that our students have been going through in creating this structure. We are using aquaponics as a STEM initiative in our earth science and environmental science courses. Our students are learning the ins and outs of an aquaponics system, including the biological interactions and the water chemistry that is involved in growing plants and fish together. We started the beginning of the year by taking IBC totes and cutting them up. Those were used not only for our grow beds, but also for our fish tanks. So here you can see students working on that. Here's some more pictures of students working. They're taking apart the frames, getting the IBC totes taken out, and we had to do quite a bit of cleaning of them because we actually used some that had contained Roundup in the past. So we had to spend a great deal of time cleaning that out. Half of my class worked on the larger system, the other half of the class worked on mini systems. Students that did mini systems, most of them just took aquariums. They used some foam board, insulation board from Home Depot or Lowe's. We cut holes in it and put 3-inch net pots in it. And then students put grow material inside the net pots. We supplied the system with some fish. We just ended up purchasing cheap goldfish from Myers. And we took each one of those systems, input a certain number of fish in them. Somebody accidentally spilled some water over here. A little science humor. And the fish inside of each one of the small systems did what fish do in water. They produced some ammonia. The ammonia was converted into nitrites, and the nitrites converted into nitrates, which then supply our plants with nutrients. So this was the beginning of the mini systems. You can see a bunch of them set up there. Over the course of the class, our plants started to grow. We did mostly hydroponic type plants, lots of lettuce. We did some kale. We tried cucumbers. Cucumbers grew really well inside this system as well. One student chose to do some bean plants. You can see some bean plants growing here. The large system was framed up using wood. You can see the students working on the frame on the bottom there. They did quite a bit of construction. Took us about a month and a half to do the actual construction. And that was in 1 to 2 class periods every day or two. So we form fitted all the IBC totes once we had them cleaned out. We started getting everything set up in the area where we were working. Currently, we're only doing 1 set of grow beds. Maybe in the future, we'll take and put a second set of grow beds off to the side there. Based on the amount of gallons from the IBC totes and the fish that we can house in there, we should be able to also do a second series of grow beds as well. The grow beds that we have right here are just flood systems. Maybe in the future we'll do a flood drain system with some bell siphons, but for right now we're just doing a flood system. Students painted the IBC totes blue. That's an effort to minimize the amount of algae growth within the system. We're trying to keep out sunlight. The more sunlight we keep out of the system, the less algae growth that we'll have. We used just regular PVC. We used purple primer and glue to glue them together. Students did a lot of measuring. They did a lot of design. This is where students started to put all of the system back together, get the grow beds in place after the paint had dried. What we found as we were going through this and developing our system, initially I had just thought that the walls at the bottom could be used to support the totes, but we found as we were going through and doing that the amount of water we were putting inside of the grow beds and inside of the tanks, the weight was too heavy, and so the grow beds and the tanks started to sag around our walls. So we actually went back in, drained some things back out, and we just went and got some sheeting, cut it to size. We ended up just fitting it underneath the two walls. In this case, with the larger IBC totes, we fit it underneath the entire tank, but in the grow beds, we just ended up fitting it underneath the wall that we had on the bottom here. And then that also gave us space at the edge in order to put our drain in one side. So you can see where we've got the drain hooked up. The drain's just running through down this side, and it's running over into a sump. Our larger tanks are being filled from the sump through a pump. They're being drained into these two 55-gallon barrels in the center. Those are our biological filters. That's where we're housing bacteria and trying to promote beneficial bacteria growth. And then the water from the biological filters is through gravity being fed out into the grow beds. Here the students are hooking up our water supply. You can see them testing it here. Water's coming out, and we had to actually adjust the amount of water that was coming out of each one of these in order to get relatively similar flows out of each one. Right here, students are starting to fill up the system, finishing up some last-minute modifications to things, adding a few extra screws in places that we overlooked them. The sump tank was kind of an interesting thing for us. Initially, I thought that going with a very large pump would be a benefit. I thought if we had the system pumping a large amount of water, we would increase dissolved oxygen. What I found was that as we were increasing the amount of water that was being pumped into each one of our 330-gallon tanks, the drain wasn't working near as fast as what the pump was. And so we had to adjust that. So what I did was I threw a T in, thinking that I could just circulate water inside of the sump tank, and it would just cause water to, as needed, go up into the tanks. What I found was that when you put a T on here, especially one with a sweep on it, the water just circulates inside of the sump. It doesn't matter if you open up the valve completely right here, the water just continues to circulate in here. So what I ended up having to do is I had to come back and put another valve so I could turn down the flow of the water inside of the sump and open this valve up so that I could get my amount of required water going into the tanks. Now I also had to put in a valve here, a flow valve, in order to keep the water from siphoning back into the sump tank when the tank shuts off. So I'm not running our sump all the time, our pump on the sump all the time. I've got a timer on it, so what ended up happening is when we shut off the timer, that water would flow backwards into the sump tank and it would fill it up. And if I wouldn't have noticed it, we would have just flooded over top of that, and we would have had too much water, actually flooding the school in that instance, because all of the water from these two tanks would have, through gravity and the adhesion and cohesion properties of water, it would have just pulled that water right back out into the sump tank and flooded over the top of it. So note to self, as you're starting to look into getting a pump and regulating pumps, my pump does not have any type of regulator on it, so I had to do something just with the flow. If you're going to purchase a pump, either make sure that you have a regulator on it, because you can't use a dimmer switch of any type. That just heats up the pump and causes electrical problems, could eventually lead to fire. Make sure that you have a plan for how you're going to go about regulating that system. And your plan may be just as easy as what my plan was, where I threw a T in there and a couple of valves. It cost us a little extra money, but it seems to be working great right now. Plus, I've got a lot of water cycling inside of the sump. which is going to increase my amount of dissolved oxygen. So this is our entire system. It's almost complete. We still need some grow lights to be added to the system. We have an individual that is willing to donate some fish to us. So one of our tanks are going to house rainbow trout. We're also considering the possibility of taking another tank and housing maybe tilapia in another tank. But ultimately we're going to have to look at the amount of waste that's being supplied to the plants. Is that amount of waste appropriate to the number of grow beds that we have? So there'll be a lot of mathematical analysis that we have to do, some data analysis that we'll have to do over the course of the next year or so. This tank right here we have set up with just some floating beds. These tanks we're going to eventually fill with clay pellets, and so clay pellets will be in here, and we'll just plant our seeds directly in that clay material. It's just another picture from another angle of our system. You can see the plants that we've got transplanted into it. Eventually we'll cut some more holes inside of the float material, and we'll continue to add more and more plants. So I hope this helps to explain our aquaponics system, what we're doing here at Fulton Schools, and ultimately we're really looking for student learning. We are trying to get better and better at this. It's going to take us some time though. I'm learning at the same rate that our students are learning, and eventually we're going to find a happy medium between me being able to supply the information that's needed and the students going out and doing research and coming up with their own information and their own data to help support plant growth and also fish growth.